Welcome to calculus class. Today's lesson is on motion with integration and arc length. We're going to start by looking at the arc length formula. You've got some new note cards for today's lesson. This is one of them. Arc length, which we can use a capital L for, is equal to the integral from a to b of the square root of 1 plus f prime of x, so that's your derivative of f of x, squared dx. Now, this is a no calculator problem, so we're going to do this one without a calculator. And so for first, it gives us x values 0 to 4. So those are our a and b values. And then we're going to take the square root of 1 plus. We need to figure out what the derivative of our function is. We have y equals x to the 3 halves. So y prime, the derivative of that, would equal 3 halves x to the, subtract 1 from the power, 1 half power. So in the parentheses, I'm going to go 3 halves x to the 1 half power, and then squared dx. So we're going to do this integral without a calculator. So the integral from 0 to 4, square root, 1 plus, this would be 9 fourths x to the, let's see, 1 half squared. When you raise a power to a power, you multiply the power. So 1 half times 2 is 1. And then we're going to have dx. Now we may want to think of this as all being raised to the 1 half power and do a u substitution. So if we were to do that, u would equal the stuff under the root, 1 plus 9 fourths x. So du dx would equal 9 fourths. So du would equal 9 fourths dx. And we don't have an extra 9 fourths, so we'll multiply by 4 ninths to isolate our dx. And remember, when we do a definite integral with a u substitution, we also have to change the limits of integration. So u of 0 is going to be 1 plus 9 fourths times 0, which is 1. And u of 4 is going to be 1 plus 9 fourths times 4, which is 10. So we're going to come over here and say the length is equal to, we've changed our limits. It's now going to be from 1 to 10 instead of 0 to 4. And we're going to have u raised to the 1 half power, and the dx is coming out, and 4 ninths, which I'll put in front, du, is going in its place. So now I'm going to integrate by doing the power rule backwards. So if I add 1 to my power, I'm going to have u to the 3 halves. And then I'm going to multiply by the reciprocal of that, 2/3, which multiplies by the 4 ninths I already had. And we don't do a plus c because this is a definite integral. We evaluate it from 1 to 10. So this is going to be 8 over 27. And then this is the same thing as the square root of u cubed. And we are going to evaluate that from 1 to 10. Remember that when we do a definite integral and we change the limits, we don't go back to x at all. So this is going to be 8 over 27 times the square root of 10 cubed minus 8 over 27 times the square root of 1 cubed, and we can do the square root of 1, that's just 1. So this means it'll be 8 over 27 times the square root of 10 cubed minus 8 over 27. And that is the answer to this problem. Now, what does this mean? What did we just find? Well, it's kind of like if you laid a string down over the x to the 3 halves function, starting at x equals 0 and x equals 4, then laid it out straight to find out how long that function is. This is the length, okay? It's almost like the distance formula except for curves. Now, number 2 says use a graphing calculator to find the length of the curve. Y equals 4x minus x to the 1/2 from x equals 1 to x equals 4. So this time we're just going to set it up and put it in the calculator. So the integral from 1 to 4, they have to give you somewhere to start and somewhere to end, of the square root of 1 plus, we need the derivative, y prime is 4 minus 2x. So we're going to have 4 minus 2x quantity squared dx. And that's all the work that has to be done if it's a calculator problem, so that's nice. So I'm going to go, let's see if I can get this where you can see it. Alpha, window, number 4 for function integration. Plug in 1 for the lower limit, 4 for the upper limit. Square root of 1 plus parentheses 4 minus 2x, close parentheses squared, and then dx. 6.12, that 7 will make that a 6. 6.126. And that's done. Okay, if we were in class together, I would now have you do problem number 3 with your people in your groups or nearby, partner pairs, but since you're working at home today, maybe you should pause the video and try this one on your own and then play it to see if you got it right. All right, I'm going to assume you have stopped and tried this one on your own, so I'll just tell you the answer is 5/3. So if you got 5/3, you could probably fast forward to the next question. If not, let's make sure that you know how to get 5/3. So we're saying that the length is going to be equal to the integral from 0 to 1 of the square root of 1 plus, we need the derivative of this function. So y prime equals 3/2 times 2/3 is 1. So x squared plus 1, subtract 1 from that power, which would give us 1/2. Then multiply by the derivative of the inside function, because we're using the chain rule, which is 2x. So you could also say that's 2x times the square root of x squared plus 1. So that's what goes inside parentheses or brackets or whatever grouping symbol you choose to use, squared dx. Oh, excuse me. All right, so now I'm going to simplify. Excuse me, never just one sneeze. Okay, so 1 plus 2x squared is 4x squared, and then when you square the square root, that comes out of the square root. And now I'm going to simplify under the radicand. I'm going to simplify the radicand, which is under the radical. Excuse me. 4x to the 4th plus 4x squared dx. Now, I don't like the way those numbers are not in the right order. You know, I'm a math person. I want descending powers of x. Otherwise, it just looks wrong. Okay. Look at that. Does that have a square root? I believe that does. How lovely. This is, the square root of that term is 2x squared. Square root of that term is 1. 2x squared plus 1 quantity squared. So then if I take the square root of a square, those undo each other. And I have 2x squared plus 1 dx as my integrand, which is super easy to integrate because I just do power rule backwards. So this is going to be, let's see, x to the 3rd, and that's times 1/3, so 2/3 plus x evaluated from 0 to 1. So now I'm going to come over here and sub in my upper limit of integration 1 to both x values. And then subtract what I get when I sub in my lower limit of integration 0 to both x values. And now I've got 2/3 plus 1 minus 0. So I believe that would be the same thing as 1 and 2/3, or you could say 2/3 plus 3/3 and call that 5/3, which is what I told you the answer was. So that's how you get it. Okay, so this was 3 problems worth of practice on arc length. On the back, we have problems that are about motion. So you've already learned a lot of motion formulas, and if you don't have those readily in your brain, you may want to, pull up your note cards, find the motion ones, keep them handy because they're going to come into play in our lesson today. Just as a reminder, if you have your position function, you can take the derivative of that position function. Oh, I guess it would be d dt. That's going to give you your velocity function. And if you take the derivative of your velocity function, that's going to give you your acceleration function. Okay? Now, conversely, if you integrate your acceleration function, that's, oh, I forgot the dt. That's going to give you your velocity function. And if you integrate your velocity function, you're going to get, your position function, okay? So the graph to the right shows the velocity v of t of a particle moving along the x-axis for time values from 0 to 11 inclusive. It consists of a semicircle and 2 line segments. Use the graph in your knowledge of motion to answer the following questions. So, at what time t from 0 to 11 is the speed of the particle the greatest? Well, remember that speed is equal to the absolute value of velocity. So we're really looking at where is this velocity the farthest from the x-axis. Up here is the highest it gets, that's 3. Down here is the lowest it gets, that's -6. Since it's absolute value, that -6 is going to be the biggest, but it says at what time is the speed the greatest. So we want the time value that happens, and that's going to be at time 8. Okay? At which of the times t equals 2, 6, or 9 is the acceleration of the particle the greatest? Explain your answer. Well, acceleration is equal to the derivative of the velocity. So we have a velocity graph, so the derivative would be represented by the slope of v of t. So let's look and see what the slope is at 2, at 6, and at 9. So at 2, that's a horizontal tangent line, so I'm going to call that 0. At 6, let's see, this is a line, so down 1, 2, 3 over 2, -3 halves. Doing rise over run here. And then at 9, rise 1, 2, 3, run 1. So when is it the greatest? At what time? Time of 9 is when it's the greatest. And it says to explain your answer. So by showing these 3 slopes, I can see that the greatest one is at 3. Okay, the next question says, over what time interval or intervals is the speed of the particle moving to the left? Explain your answer. Okay, it's moving to the left on the x-axis when the velocity is negative. So that's where we have negative y values, which is from 4 to 10. Time interval, 4 to 10. Over what time interval, or intervals, is the speed of the particle decreasing? Explain your answer. Right, we talked about speed increasing and speed decreasing, or we talked about speeding up and slowing down last semester. You should have note cards on that. So it is going to be slowing down, which is the speed decreasing, when the velocity and acceleration have opposite signs. If they have the same sign, it's speeding up. If they have opposite signs, it's slowing down. So up here, my velocity is positive. So I want to look at where's the slope negative. So that's going to be from here at 2 to here at 4. It's got a negative slope. That means the acceleration's negative, but the velocity's positive. It's positive slope here, positive slope here. So the only place above the x-axis is from 2 to 4. Now below the x-axis, my velocity is negative. I have a negative slope here, so that's speeding up, but I have positive slope here. So that's the opposite of the sign of the velocity. So it's going to be slowing down, or the speed is decreasing from time of 8 to 10. Okay, number 5. This one's going to use another one of our new note cards. So it says, find the total distance traveled by the particle over the time interval from 0 to 11. So this, we learned one method for doing this in the fall before we learned integration, but now we're going to have a new way to do it. It's the integral from whatever a to b. Here we've got 0 to 11, so those are the values where we start and end. And then we're going to integrate the absolute value of v of t dt. That's going to give us total distance traveled, okay? So this is going to be the integral from 0 to 11 here, absolute value v of t dt. So what does that mean? I want the area between the curve and the x-axis, and I want all of it to be positive, okay? So right here I have a semicircle, so that's going to be 1/2 pi r squared. And then I have a triangle, so that's going to be 1/2 base times height. And right here I have another tiny triangle, so that's going to be another 1/2 base times height. So the radius of this semicircle is 2, so we're going to have 1/2 pi times 2 squared. And now I need a base and a height for the big triangle and a base and a height for the little triangle. So this one has a base from 4 to 8, which would be 6, and a height perpendicular to the base of 6. And remember, I'm using positive values because we're doing the absolute value of the velocity, so we want all our areas to be positive. And now this one has a base of 1 and a height of 3, so 1 and 3. And now we just do the arithmetic. 4 divided by 2 is 2 pi plus, this is 36 divided by 2 is 18, and then 3/2, or 1.5, so 2 pi plus 19.5 is your total distance traveled. Okay, number 6, find the value of the integral from 0 to 11 of v of t and explain the meaning of this integral in the context of the problem. So this is another new note card that we have today. This one is the displacement, okay? So displacement of particle is the integral from a to b of just v of t dt. And so what is that value? We need to figure it out. So we're doing it from 0 to 11. So notice these areas, we've already integrated this. The only difference is this is a positive area, this is a positive area, and now this is going to be a negative area. Because all we've done is remove the absolute value bars. So now positive's positive, negative's negative. So this area of 2 pi is still positive, but the area of the big triangle, the 18 area, is now a negative. And then the 1.5 is still positive. So that means it's going to be 2 pi minus 16.5. And what does this represent? Okay, keep in mind, y'all, whenever you explain the meaning of an answer on the AP exam, you have to explain all the nuts. N is for number, U is for units. And did they give us units in this problem? They did not. So we don't have to use units if they didn't give them to us. T is for time, and S is for situation. So we don't really, well, we have a, situation that this is the velocity of a particle moving along the x-axis. So the displacement of the particle, so this is relating to the situation along the x-axis, is 2 pi minus 16.5. It would have units if they gave us units in the problem, but since they didn't, we don't need them. From t equals 0 to t equals 11. This is super important. These limits of integration are the times, and they need to be included in your explanation of meaning. So I've got the number that the answer is. They didn't give me units, so I don't need that. I have the time, and I have the situation, all referenced in my explanation. All right, the last one says, if the initial position of the particle is x of 0 equals 2, find the position of the particle at the time t equals 11. So this is another new note card that we have that's called the new position. So if you have S of f, which is your final time, equals S of I, your initial time. Well, final position equals initial position times plus the integral, from I to f, initial time to final time, of v of t dt. So this is what's on your note card, okay? So let's fill in what we know. Well, we want to find the position of the particle at the time t equals 11. So that's our final time. So 11 is the final time. Okay, what's the initial time? Well, x of 0 equals 2 is the initial position. So at 0 is the time that occurs. So 0 goes here. And then we've got v of t dt. The initial position is 2. And we're trying to find the final position, which is at the time 11. Okay, so the position at time 11 is equal to the starting position 2 plus the integral from the initial time 0 to the final time 11 of the velocity function, which is our graph. So we've already found this integral. The integral from 0 to 11 of v of t dt was 2 pi minus 16.5. So I can replace that, 2 pi minus 16.5. And just add 2, and that's going to give it to me. So, combine the like terms here, 2 minus 16.5, and I'm going to have S of 11 equals 2 pi minus 14.5. That's the answer. All right, good luck on your assignment. Study your note cards, practice. Let me know if you need any help, and have an absolutely wonderful day. Bye for now.